Thanks, everyone. So my name is Chris Basham. I am a designer and front-end developer for Indiana University down in Bloomington. And so for the last several years, I've been experimenting a lot with trying to figure out how to build enterprise applications and how web components and whatever fit together. So for me, my journey kind of started with using Angular way back 10 years ago, whatever it was, transitioned into React and got really inspired by some other tools like Cycle.js that end up introducing me to things like Arcs.js. So I'm going to share with you where my journey has gone from that point. So first of all, who has used React? So most everybody is familiar with it at least some level. Great. So so this presentation is going to be split into a lot of different sections, each kind of diving into different parts of what it means to build out a component. So we're going to be talking about how to set up life cycles for components, how to do rendering, what is how to flow data within a component, and then ultimately how do components talk to each other. So we'll see how far we can get with all this. There's a lot of stuff to go over. So to start off with life cycles, I'm really thinking of some simple things. So we have, when is an element added to the DOM, and when is it removed from the DOM? From the React world, that's basically component did mount, component will unmount. And with React, you're primarily saying, I want to render between those two primary things. So what I want to do is, can we build out those life cycles without React? And so to begin with, if you want to do one thing for an element that already exists on the DOM, you can just do something like this. You just say, I'm going to query select a particular thing and run it through a function. You can also do something like, maybe there's a lot of different things that I know exist on the DOM, and I want to run through each one of them and do something with it. You could do something like this. You can also do web components. So this is using the custom element spec. So this is an example in which you have a custom element that extends the HTML element, and then you have a constructor from it. And then you just register it with the browser using the define method. And you can use it by just saying, my elements in brackets. There's also another variant to this in which you can extend an existing DOM element. You can just say, you use the is attribute. So a paragraph is my element. So you're just enhancing something that's already there. A problem that I have with custom elements is that, well, the support isn't fully there. So if you're in a position like, say, me, where you're dealing with enterprise applications, you're going to need to handle browsers that are, not all the bleeding edge. So that includes IE and Edge. So can we do this without polyfills? Can we do it a lot lighter? So I'm going to aim for an API that looks kind of like this. We can say, when added, I want to search for all elements that match this particular CSS selector. And whenever that happens, I want to call a function. That function will end up receiving that element, and then you can do whatever you want with it at that point. So if we kind of use this as our endpoint, how do we get there? So a foundational piece for this, we can use the mutation observer. Has anyone used the mutation observer? Know what it is? OK. 1.5. So yeah, this is kind of an obscure API that actually goes back pretty far. and basically allows you to listen in for whenever there are DOM changes. And so you can set it up simply like this. You say new mutation observer, and you pass it the function that would be called whenever there's something that happens. And you have to register it against some element, and you can give it some options. So in this case, we're saying, I want to observe the entire document, so everything that's in HTML. And more specifically, I don't want to just listen in for changes to the document, but I want to listen in for changes to any elements that might happen underneath it. So we're basically, at this point, any time that there's a new element that's added or removed anywhere in the HTML document, we will end up noticing that. And so every time that that happens, it executes this function. Now, the mutation observer does actually give you some other things here. There's something called like a mutations list. So it can actually be a little bit more specific and say, this is exactly what the change is. For our purposes, it's actually a little bit simpler to just ignore that altogether, and we can just do checks, even if a lot of them will just come up empty. It just kind of simplifies the code underneath. So let's try something like this. What this is doing is whenever anything happens within the HTML document, I want to just run this function. So we're going to say it's called check counter, whatever that means. So this function is down below here. What this is going to do is it's going to query the DOM and say, find me every single element that has a class name of item. So at this point, we're going to say, well, have we already registered this element with what we're trying to do here? Have we already called that initialize function that we had talked about a few slides earlier? So this filter is basically just saying, well, if it has been registered already, then I'm just going to skip it. So this makes sure that we guarantee to call that initialize function once, not every single time. And then we call a for each. So what we're doing here with added counters.add, we are just using a set data structure. Has anyone used set before? So set is, it allows you to have similar abilities as an array, except for it means that only one, you're guaranteed that any element that you put in there will be unique. So you'll never have duplicates. So what we can do here, it gives us the ability to say, is anything in the set? You can just say has. If you did this with an array, you could easily just say, index of, and whether it's -1 or not. That could be a way to check it. And then here, you can just say, you just add in the element, and then it's registered, guaranteed that it's unique within that set. So anyway, at this point, line 15 is where you can do any other things that you might want to do now that you guarantee that you're initializing one time for any time that a new DOM element with a class name of item gets registered. And at the bottom, we're just going to call it once, just because you're not guaranteed that the mutation observer will be called, because maybe nothing does change on the DOM. So you call check counter once to at least make sure that anything that's already there gets initialized. So this is a good place to start, but we're still kind of locked in to one sort of selector. We need to still abstract this out a little bit. So now we're building out the API that you kind of saw earlier. So we say when added, we provide two different arguments. One is selector, one is the callback. And what we're doing here is we're actually going to be introducing one more set. And this set is all about registering all of those unique callbacks that you might end up setting up. So if I call when added once, there will just be one thing within the when callbacks set. If I call it twice, there will be 2 things. And what you're saying is, I can call when added as many times as I want to register essentially any number of different types of components. So I am, all of this innards is basically the same thing that you'd seen on the previous slide. The only difference is rather than this initialize comment block, I am now executing the callback that is passed up here, and I'm passing in the element that is discovered through that query selector. So we can extend this one more time. So if now we have an ability to say, when is this element added to the DOM, we also need to figure out the cleanup part of it. So we need to provide a method to say, when this element is removed from the DOM, I want to hook in at that point. So we can just add another thing. It could be called, say, when removed. And at this point, you can just say, when a particular element is removed, do this callback. So this just hooks into the same when callbacks set that we did earlier. And we can just go ahead and add in this function that will, again, be called every single time that the mutation observer gets called. And all we're doing here is saying, well, is this element still around? Is it still within the document? If it's not, then we continue on. We go ahead and clear out that function from the when callbacks set so it doesn't get called again. And then we go ahead and execute that when removed callback there. So we can use it just like this. We can just say when removed, we pass in the same element here that we received from when added. And we can clean this up even one more time if we really want to. And this is just integrating those 2 pieces. So now we go back and we have a cleaner API that we initially wanted, that we started off with. So again, our signature is, we have this one function called when added. We pass it any sort of a CSS selector. We pass it a callback. It'll receive an element. And then you can return another function that will be called whenever it's done with. So you can actually use this now. So I published this last week. And you can get the when added and when removed functions. There's a little bit more in there that I didn't go over here, but you can use it right now. And it's ½ a kilobyte once you minify it and gzip. So that's pretty rad. Any questions about that before I go on? And we'll get into some demos so you can actually see this live. Okay. So we've covered some basic lifecycle stuff. How about rendering? Rendering is the next step. So what we want to do is figure out a good way to be able to mutate the DOM, update it. And of course, it needs to be fast. An animation frame is 16 milliseconds. You should be able to be faster than that. A popular way of doing this is using the virtual DOM. This was kind of headlined by React a number of years ago. And what a virtual DOM is, you're essentially just duplicating in memory everything that's within the document object model. And in order to make it a little bit easier on developers, you end up having, you can write essentially HTML within JavaScript, and those files are called JSX. And then, however, the browser knows JavaScript, the browser doesn't know JSX. It'll just balk at that. So you have to transpile JSX into JavaScript. Again, that's just another step that you have to be responsible for. But with the latest version of React and React DOM, the kind of 2 pieces that you need to at least get it set up within the browser, that's going to be costing you 40 kilobytes. There's some other virtual DOM libraries. Pre-React is one that's significantly smaller. And that's essentially the same API as React, but again, smaller. And then there's a few other ones that have been around that it's often kind of used as kind of a underlying technology to some other solutions. So with that in mind, what can we do that's not virtual DOM? Well, some popular techniques uses template literals. Have anyone used this tech? A few people. So it's really this thing here below. You end up just using tick marks rather than say quotation marks to indicate a string, and it gives you this ability to insert in expressions. So rather than saying quotation mark string, then the plus operator, and then a variable, and then another string, you can just use this. It kind of simplifies your life. It looks nicer too. There's also another thing that you can do with it, and you can actually, you can actually place a function right ahead of it. And this is really obscure because most of the time you kind of put a function in something and then you pass it parameters. You're always used to having the parentheses. This is the one thing that doesn't do that. You could do it manually in a different way, but what you're doing here essentially is you have this string and that gets passed into this tag function, and that can do whatever else that you want underneath the hood. So there's, of course, documentation on like the MDN site that you can look at to get a little bit more idea of how to use it effectively. But it's a really cool technology, and it goes back pretty far. But with template literals, the techniques that that other people are pioneering, it doesn't use virtual DOM. That means you're not using JSX, and you don't have to transpile. And these libraries are also much, much smaller than what React is. And so there's a number of them that I've highlighted. Lit.html, for example, is the underlying method that is used for Google Polymer. So has anyone heard of Google Polymer? So it's Google's way of being able to abstract out web components and provide a framework to be able to basically polyfill it while the browsers are working on the spec. So there's a couple of other ones that are really neat. One is called HyperHTML that's been out for a couple of years now. And then it kind of has a little brother called Lighter HTML that just got published here within the last few months. So I'm going to be focusing the rest of this talk primarily on using Lighter HTML as the solution here. There's a number of interesting reasons why, but that could be a future thing all in itself. There's a nice article here that kind of compares these three different rendering libraries if you're more interested in the details. But this is where we're going to start off with. And with this is really backwards compatible. I can use this on IE9, for example. That's really, really cool. So let's look at what this is. So I can import in Lighter HTML, and there's primarily two different methods that you can use. This first one, you pull out HTML. HTML is that template literal tag. So I just say HTML, tick mark, and I write whatever markup that I want. Now the output of this is going to be literally this element, or it could be a document fragment if you do something else that. So just like within JSX, you have fragments now. You could just do the same thing natively like this. So this just returns an element. Now you can also render. So with this, I just pull out the second part of the API, which is called render, which the first parameter is the element in which it's going to inject whatever you're going to do. And then the second one is you pass it a function that returns some element. So you actually could just not use the HTML tag and just send it something native using like the document create element if you would want. But this is kind of meant to be paired together. So let's kind of see this in practice a little bit more. So with this example, what I'm going to be doing is saying, I want to find the element within the document with the ID of clicker. I'm going to start off with some state. So this is just an object. And I want to go ahead and render to that element this component. So I, just for the sake of kind of showing you how you can have different functions do different parts of the rendering, I'm splitting that up here. This could easily be done in fewer lines, but again, the point is to show you how things can be pulled out and abstracted. So for here, I'm passing in the state object, and then that becomes props for these functions underneath. So for here, I'm returning HTML, and I'm using the expressions in order just to pass it a function this time. And this function will just, I'll continue to pass down props, and this will end up just displaying that static value there. So this is the markup that pulls in that code. We can see here that all that I'm doing is pulling in lighter HTML and the script that I have there. I'm doing no transpiling, nothing else like that. And then here's the clicker that it goes into. So if I go ahead and launch that, that's what you see. So we have a button with a value of 0. Now I can click this, nothing's going to happen. So this is all static. So that's okay, but it's not the greatest. So what can we do more? So with this one, what we're going to do is let's make this a little bit more dynamic. So instead of state being a const, we're going to make it a let. That means that it can be mutated. And I'm going to introduce a handler. And this is going to say, whenever the button gets clicked, I want to call this thing. So whenever I click, I want to increment the value that's within state. And then I want to call another function called update. Update, all it does is saying I want to re-render. So if I call render once, again, it's just going to be rendering once. I have to tell it to re-render. So what I'm doing here is I'm just going to be merging this state object in with this other object called handlers. I found that this pattern is just kind of a nice way to be able to have a scalable way to make a lot of different handlers and pass them in through your rendering functions. So that all gets passed through, and we can see down below here that we just put that click handler on top of the button directly itself. And everything else is basically the same. What I've done here below is line 36 is just to at least initiate it once. I call update once just to make sure that the button gets rendered. And then I'm just going to go ahead and pre-fill it in by doing some couple of clicks. So we can see here, it'll start off with value 0, and then goes to 1, and then 2. And so if I go ahead and render the preview this, again, this is basically the same markup that we saw before. We can see clicks 2. And I can continue to click, and you can see that moving up. So that's really cool. So now that we've done all of that, let's kind of integrate what we learned in part 1 with this. So we're going to take in when added, and we're going to then search for the element with the ID of clicker. And everything else is basically the same that you had just seen there. All we're doing is we're integrating it inside of that callback. So we can see here that these rendering functions are currently outside of this initialization. I basically did that because maybe there could be other when added calls that might want to take advantage of these same things. It's just a nice way of being efficient with memory. But anyway, so we have this, and I can go ahead and open up here. All that you can see that we're doing here, we are adding in when elements in addition to lighter HTML. So we have those two libraries available. And we can go ahead and present this. And now this is, again, the same thing that we had just seen before, but it's done a slightly different way. So with this when added ability, it gives us to kind of we can be a little bit more flexible with how we declare our components. So what we have just seen is we can write something where we say, here's a div with an ID, and we can just inject straight into it. We could also say, well, here's a class with, and then you're searching based on the class, and you can inject from there. We can also just say, you know what, I'm going to pass in a custom element's name, and it'll end up rendering like this. Or I could also do the same syntax, that is, I'm extending an existing element, and I could do something like this. All these things can work. So I'm going to basically just take what we had just done a few slides back. All that I'm doing is changing up the selector. All the rest of the content in here is the same. All the way down, it's the same. And now the markup is, again, slightly different. For here, I'm going to say my clicker, my clicker, my clicker 3 times. Click your heels. And now we can see 3 are there. And then they all maintain different state. So that's pretty cool. And for the, yep. Yep.
Could you just go over how they have independent state?
Okay, yeah. So, yeah, sure. So the question is, how are these things, how do they have independent state? So what happens here is, we declare when added once, but this callback function is going to be called every single time there is a unique element that matches this selector. So in this particular case, it noticed that there were 3 different elements with that tag name. So it's calling this function 3 different times. And since this state doesn't bleed over, it stays within that function bounds, within that scope. Therefore, it's unique for every single element. Is that good? Any other questions here? Okay, so I have one more slide on this section. So if you are more of a fan of some of the React API, you could, of course, abstract out some of the stuff that we've done and even include a set state function. Because with React, you're kind of used to saying set state, I give it some new state, and then it will automatically call render somehow underneath the hood. So you could essentially just simulate the same thing. So here, we're just declaring a function called setState, in which we pass it new state, and we can go ahead and merge the new state with old state, and then we call update whenever that's done. And then here at the bottom, I can just say setState once with the initial value of 0, and it's now doing the exact same thing as the slide prior. So again, just there's a lot of cool things that you can do by just kind of continuing to play with the code that you have there. So any questions on that section? Okay. The next part, we're going to talk about data flow. So when I am using an application, what you're doing is you're creating a feedback loop. You're saying that me, the human, the user, I want to do something with this machine. So I'm now launching the application or doing whatever I want to do. The application then renders. So me, the human, I am looking at what the screen presents to me. And then I make a choice. What do I want to do with what I'm seeing? Am I going to interact with it? What's happening? So my choice is, okay, I'm going to interface with this thing somehow. And my tools are, of course, with a mouse or with a keyboard or other technologies that might be available. So we have that loop that happens. The human interfaces with a computer computer responds, and it's that back and forth. So everything that we're talking about there, the data that gets updated over time, the interactions that happen over time, this can all be modeled as events. So events being, just something that happens over time. Maybe it happens once, maybe it happens multiple times, maybe it never happens. And so it's really important to make sure that interfaces in this sort of way treats asynchronous as kind of like a first-class way of work. So by default, a lot of things that we do with JavaScript is synchronous first. It means that I do something, and it kind of does the run-through. And if I want to do async, such as I do an AJAX call or I mess with promises, that's something that I kind of have to, I'm almost injecting into a lot of my synchronous code in order to make it work. So this leads me into another form of programming called functional reactive programming. So I'm going to give a little bit of a tutorial on what that is and what that can do for us in this case. So has anyone heard of functional reactive programming as a concept? A few people. OK. So we'll start with functional programming. So what this is doing is I want to be able to perform functions on data structures. And it's kind of a different way of thinking about how to write your code. So it could be really tempting to do something where I say, here's an array, and what I want to do is increment a number from that. So what I'm doing here is I'm going to be looping through every single item within this source array, and then maybe I'm going to be keeping just every other item within that array, and then I just want to multiply what remains there and then just tally it all up. It's all arbitrary, but what the point is, it's trying to show you a lot of different things that you might be doing, and you're mutating variables, you're going through loops, you're setting up conditionals. With functional programming, it's done in a way in which you write it to describe what you want to do rather than how you're going to do it. So in this case, the same thing can be written in which I say, here's an array. And in JavaScript, arrays have a lot of different methods available to themselves. So filter is one of them. I can say dot filter. And in this case, I'm just going to say, I just want to keep everything that is every other one within this source set. And then the result of filter will end up returning a new array. So it's not this original one. It's going to be a new one. And then every item within that will be looped through a map function. That means every single element will then be multiplied by 2. The result of map will return a new array. And then finally, we bring it through reduce. And every single time, for every element at that point, this function is going to be called. And what it's going to do is I'm going to take each one of those elements and then just tally it up. I'm reducing the array from maybe 4 elements to 2 elements to 1 element to 0 elements until I finally reduce it to whatever object that I decide to leave it in. So in this case, I'm reducing it down to a number. But you could reduce it down to an object or another array or another thing. It doesn't really matter. So anyway, it's 2 different ways of being able to write this. One cool advantage of this is the output of this tends to be immutable variables. So that's also kind of been a hot thing that's gone around, especially around the React world. You're using Immutable.js. Has anyone looked at that, seen that? So if you are more conscious of what your variables are doing and how they go from state A to state B, you can basically accomplish the same thing without needing another library to do it. So again, in this case, every single operation just returns a new array. And in that sense, it's immutable all the way down. So we can see here again, we're using const and no lets. Any questions on that piece? Okay. So with reactive programming, so we talked about one part of functional reactive programming. Now we're going to talk about the reactive part of it. So this is typically set up as you have streams that push data to listeners once there's data that goes on the stream. So streams are also typically called observables, and listeners can also be called subscribers. There's actually an observable spec that is being worked on. So a lot of this will be available natively in the browsers in the next number of years. But there are libraries such as Reactive.js that I'm going to be highlighting here that give us these abilities right now. And so with reactive programming, it means that everything is asynchronous in nature. If we go back to the previous example, everything that gets executed here is synchronous. It means that this array gets passed into filter, and nothing else in the browser can happen while it's going through this sequence. It's saying that filter has to execute first, and then you have, there's no like micro ticks, there's nothing else you can do. It's just waiting for this sequence to complete. So then after filter, then map has to happen, and then reduce has to happen. And maybe after you're done with this entire thing, maybe you can do something different. If this is really computationally heavy, your browser might end up just freezing. So we go back here. With reactive programming, every single one of those operations is asynchronous. It kind of gives an opportunity for any other thing that the browser might need to do, can do it in the time in between. And everything is set up to be able to, because you're just listening, it doesn't matter when another thing decides to emit, because you're just going to be ready to listen and receive it whenever that happens. And there are promises. You can, of course, use promises to do asynchronous things, but really observables can do that and much, much more. So here's an example of this. So at the top, this is showing using some Arc.js code. What this is saying is I want to combine latest. Should never double click. I want to combine the latest value of two different streams and do something with it. So what this is doing is with Arc.js, you have this pipe method that's available. And what this means is everything within pipe is going to be a series of operations that you can do that happens linearly on whatever that comes right before the pipe. So what this is going to be doing is the output of combine latest is going to be an array of the latest value of those two streams. And so I can see here that the input of this first map operation is that array that outputs from here. And then I'm going to go ahead and just add these two things together. So if I don't use observables, this is a way to write the same type of thing. I say, here's a value of A, here's a value of B, here's a value of C. And I want to be able to set the value of A. And whenever I set that value of A, I go ahead and set it. And I do the same thing with B. But the problem is A and B has to be aware that something downstream wants to be updated because these two things get updated. So you now have this kind of weird dependency where it's something that is up higher has to know about things down below. So this has to manually call update C in order for C to then update itself. With streams, it just kind of handles it all together. So Arc.js it's a library that's been available for a long number of years, and it's actually implemented. RX means reactive extensions. This has been implemented in a lot of different languages over the years. So you can actually use the same sort of API that you might be learning for ArcGIS, and you can apply it to other languages. So for example, if you use Java a lot, or Ruby, or PHP, you can actually use these very, very similar concepts on the back end or in those languages. Also, some history with ArcGIS. It was actually initialized by Microsoft, again, a number of years ago, maybe about 5 years ago or so. And then they handed off to the open source community. They published it and gave it available to everyone. I think ArcGIS 4 was the last one that Microsoft had managed. And then Netflix was a really, really big proponent of this, and a lot of their people helped to really develop it out. And we're now on version 6. And if you're really interested, you can actually go into some of their experimental branches and see some of the things that might be coming out in version 7, which, again, some really cool things. Different talk, maybe a lightning talk. So with ArcGIS, the latest version, it is 28 kilobytes. But of course, a lot of that is just all the different operators that might be available to it. So there's a lot of stuff there, but you can also tree shake it. So if you know of Webpack, has anyone used Webpack? So Webpack is a bundler. It just allows you to be able to compile your code down. There is an ability in there called tree shaking. There are other bundlers that can do the same thing. Rollup is another one. But basically, it means that here's this big library, and I only use maybe 5% of it. So can I just throw out the rest and just keep the little bit that I want? And so that could be a way for you to be able to reduce a lot of the file size that ends up being sent off to the browser. So with ArcGIS, there's about 150 different operators. So there's a lot of stuff to learn. There's a lot of depth. What I found is if you're trying to do something, you're using ArcGIS, but you're kind of almost working around it a little bit. I found that oftentimes they're just an operator that you haven't yet learned. So just spend a lot of time with the documentation if you're interested. With ArcGIS 6, and maybe even a little bit of version 5, they introduced an ability to inject custom operators in here. So it's really easy for you to say, well, if all of these 150 don't work for me, I can do something completely myself. And anything that you do is now really at the same level, the same class that they use natively in the library. Everything gets run through the same pipe method. So if you're interested, I have set up a document that is kind of a lot of different things that I struggled with as I was trying to learn this tool. So this is available to you. One thing that might have been a little bit weird, as you saw through some of the other slides, is what's up with that $sign. So that's just a convention. It's just a nice way of saying this variable is a stream. You just put on that postfix, and that's really all it means. You don't need it at all. It's a convention. But if you see a lot of examples online dealing with streams, that's what they're doing. So there's a lot of other things that go much, much deeper into here. Again, if you're interested, you can read through it. And from those, there's a good subset that you can kind of get started with if you're trying to learn these different operators. Here's a little over a dozen. That's a good place to start, so you're not just overwhelmed with 150 and like, where do I start? So let's look at a few different examples. So for here, what this code is using CommonJS. Basically, what that means is I'm going to be running this through the terminal and having Node run it. That's why this importing syntax looks a little bit different than what you've seen on some previous slides. But for this example, I'm going to show you that I want to set up something that does an output every second. So interval is one operator, and the one argument that you give it is how much space is in between every tick, every emit of it. In this case, 1,000, meaning 1,000 milliseconds. So every time that that happens, I want to then take what is returned from there and run it through a map function. In this case, what happens is interval will end up first emitting the value 0, and then the next time that it emits, it'll be the value 1, and then 2, and then 3, etc., into infinity until you terminate it. So what we're doing here is we're just going to be making the 0 a 1, the 1 a 2, etc., and then we're adding in this s to indicate seconds. And then at the end, we say .subscribe. And then we're just passing in that value, and then we're going to just log it to the console. So .subscribe is what you always need to end with at the end of a stream. This is what will initiate it all. This is saying, I'm listening to this. Go ahead and start. So if I go ahead and copy this and run this, you can see it's now ticking 1, 2, 3, 4, 5 into infinity until I decide to say no more. So that kind of shows you some basics of I'm producing content and I'm manipulating it. So let's look at some other different pieces here. So how do we get data into a stream? Well, you can use from event, and this just means that I want to pay attention to every single click event that happens everywhere within the document. That's what line 5 is. On the next example is what we had just done before. I just want to have a tick that goes every increment of time. Maybe I just want to have a stream that just has one value. It's just, in this example, a string. It sends it off, it emits once, and then it's done. In this case, down below, I'm using from, and I pass it an array. And what this is saying is I'm going to emit these 3 things in sequence. So it's going to emit A, and then going to emit B, and then emit the value C. In these next 2 examples, we're going to be setting up a custom stream. And so this uses 2 other things. They're both kind of called subjects. And essentially, they're kind of empty vessels in which you can inject whatever you want in there. So in this case, on line 21, I'm going to say, I'm going to create a stream called movies, and I say new subject. So that creates the stream. And then with the next values, what I'm going to be saying is movies.next. So what I'm doing is I'm forcing a value on that stream. So anything downstream that is listening to the movie stream will end up getting that value. So in this case, what I'm saying is first that the future happens, and then part 2 happens, and then part 3 happens. The last example is using behavior subject. So with this, it's saying that there's an initial value, and this initial value is the string of 1985. So with the previous example of just subject, there is no initial value. There could be a movie, there could not be a movie. I don't know. One many or none. In this other case, it's saying you at least start off with a value, you guarantee that you have something, and then that value can change over time. So in this example, I'm sitting there in the DeLorean, you have your time coordinates, and then I go from 1985 to 1955, I save my dad, and then I go back to 1985. Any questions about that so far? So let's see how this combine latest thing could work that we kind of did earlier, and let's expand it out a little bit. So what this is doing is I'm going to go ahead and start ticking through this interval, and stream B is going to be listening for that. And every time that that happens on stream A, I'm going to run it through these other filters, these other operators. So in this case, I'm going to do the same thing where I say I just want to keep any even number, and then I want to multiply any remaining ones by 2. And then at the end, I'm just going to go ahead and combine latest those 2 different streams. The output of that will be an array. So we're going to go ahead and execute this and see what it does. What I'm showing here in the comments is basically what this sequence is doing here. I'm just seeing it executed over time through the x-axis. So I can see that I get the value of 0, 0, then 1, 0, then 2, 0, etc. down the line. So again, we are emitting new arrays dynamically every second. So let's kind of take what we've learned there with our Reactive.js, what we've learned with lighter HTML, and what we've learned with when added, and let's start to combine them all together and see what happens. So in this case, we're going to say, when I notice anything in the browser that is a timer, I want to go ahead and initiate this interval, and I want to transform it. In this case, I am just taking all of these seconds, and I'm going to end up putting it inside of a state object that then gets subscribed to and gets pulled in and displayed. Here at the end, because you're being a good developer, you want to make sure that you clean up after yourself. So in this case, every time that I subscribe using Reactive.js, I need to make sure that I unsubscribe someplace. Otherwise, that could lead to memory leaks. So in this case, it's saying that I only care about listening to state whenever this DOM element is actually in the browser. So when the DOM element is removed, I can unsubscribe from it. So in this case, I just say subscription.unsubscribe, and then I'm done with it. Memory is cleaned up. You're good to go. So before I get going with those operators, I want to go ahead and comment that out, and then I'll add them back in one at a time just so you can kind of see what happens here. So I'm going to save this, and I'm going to open up here. So this is, again, the markup. We can see that we're pulling in our 3 dependencies. We have our timer, it's a div with the is attribute. So if I go ahead and execute this, we can see that it was blank for that first second, and then it gets going after that point. So it's blank, and then it's 0, and then it's 1, then it's 2. That's not quite what we want. We actually want to make sure that it emits something at the very beginning. I don't want that blank screen. So if we go back here, that's what this start with operator does. It says that even though interval will wait a second before it emits its first thing, and then wait another second before it emits the second thing, start with says, I'm going to start and immediately emit 1 value. In this case, I'm going to emit the value 0. So if I go ahead and save that, then I go back here and then do a refresh, I can see that it immediately just renders. You can just see a very, very quick flash, but it's not waiting that full second. And you can actually see here another thing, which is I'm emitting the value 0. I wait a second, and then interval emits, but interval emits the value 0 again. So I'm actually seeing the value 0 for 2 seconds. So if I refresh that, then that's going. So in order to solve that problem, I can go back, and then that's where my map function comes in. I'm just incrementing that value by 1. So if I go back here, 0, 1, 2, 3, etc. Yep.
How was it informating without the map?
So, oops. Without the map function, or even without the start with, you still have this interval that is being created. So you are creating a stream there, and I'm just piping in nothing. It's just basically meaning I'm not doing any operations on it. So this is still a valid stream. Whenever I do any one of these operators on it, if I do this, I am actually returning a new observable, a new stream. And then whenever I do this, I'm returning another new stream. So every single operator is returning a new stream, a new stream, a new stream, just like when we go back to our previous example many, many slides ago, where I'm using functional programming, where this array, every operator is returning a new array. It's the same concept. So I don't have to have any operators in order to make it work, but that gives you these other abilities to do transformations on it. So this stream called seconds $sign gets passed in here, and this can have different operators on it. This state then gets picked up here, which then gets subscribed to. So none of this up above would ever be executed if I didn't run this subscribe. It would just kind of say, well, no one's listening, so I'm not going to bother. Now I've abstracted this just to kind of show you that I'm naming this state to allow you to say that I'm preparing this for injecting into my rendering functions. But you could of course condense this down if that's what you want to do. Does that answer your question? Okay. Yeah. So there's very few methods that are built into ArcGIS observables. So .pipe is one, and .subscribe is another. .next you've seen, that's a special case. But yeah, there's very few things that you have to learn at that point. Okay. Any other questions about that piece? Yeah. Okay, so the difference between pipe and map. So map is an operator, and start with is an operator. It's saying it's a function that returns an observable. Pipe is basically just saying it's a way to send off to execute any number of operators in sequence. So pipe will do nothing if you don't provide an operator. It just provides a mechanism to contain them. Yep.
That pipe is always on state.
So pipe is available to any stream. So the interval this comes from ArcGIS. So whenever I execute this, it returns a stream. Therefore, I have pipe available to me. I have subscribe available. Those are things that you just have natively. Okay. Okay, where are we? Ew. Anyway, okay, so we have that timer. So I have one more piece on this section, and this is how do we go back to that clicker example and integrate that with ArcGIS. And in this case, what we're doing here is we're saying new behavior subject. So if you recall before, behavior subject means I'm creating a blank stream that at least starts with an initial value of, this case, 0. And what I'm going to do is I'm going to set up another stream, and this is going to be my listener. I can say from event. From event, you pass it 2 different arguments. The first one is what element that you want to use. In this case, I'm just pulling it down from what when added gives me. And then I want to say, what am I listening for? In this case, it's a click. So I'm going to subscribe to this. And what I'm saying is every single time that I notice that click action, I want to push a new value on this count stream. So I'm going to say count.next. So again, .next is available to you if you're using it against a subject or behavior subject. And then I need to somehow get the current value out of that stream. Because a behavior subject is something that you guarantee has at least one value, it gives you another extra thing, which is this .getValue method. So that allows me to get the latest value. So I say count getValue plus 1. So that's what I'm in. So I'm incrementing in that way. Now everything else below looks pretty similar to what you've seen before. We have, we're building up our state stream. We're subscribing to that, and we're passing things down below. And then down here below, because we have two different subscriptions, we then need to make sure that we can unsubscribe from multiple things. And that's what we're doing there because we're a good developer and we clean up after we're done. So if I go ahead and execute this, we can see that this just behaves in the exact same way that we've seen some of our previous examples that wasn't using ArcGIS. Any questions about any of that? Okay, I need to be really fast. Another section that yeah.
With pipe.
Mm-hmm.
The way I understand it is like basically a syntactical convenience. So like we could wrap the initial string with a function as an alternative. Like is that
yeah, yeah, in a sense, like if you're familiar with doing chaining, chaining methods. Oh, yeah, yeah. Well, yeah, same concept. You're just feeding one thing into the next thing, into the next thing. But yeah, I mean, you could easily have a function that that's X autocomplete. AAA. This is not working. Anyway. You can execute one inner function, you pass a result to the next function and pass it to the next one, and you kind of have this kind of parentheses explosion that happens. You have dot chaining, which kind of solves that a little bit. That's actually what an earlier version of ArcGIS did. It basically had every operator available on the stream, and then with the latest one, they stripped out all of that dot chaining and said, we're just going to use pipe. And so that way you can just plug in operators as you might need them and you're not overloading the API of every stream. So does that help?
It does.
Okay. Okay. So the next section that I want to talk about is hooks. Since there's a lot of React people out there, I assume you guys have heard about hooks. Maybe you've used it. It's just kind of came out with the latest version of React last month, and it was introduced back in October. And so this is a pretty interesting thing where you can start to group logic in interesting ways. This is a screenshot. Here's the source for it. That kind of shows that this code, which is a React component, was kind of written in this way, and the different colors represent different major concerns. Using hooks, it allows you to then kind of start to group things together. You can see that all of these, most of the blue is grouped together at the top, and then down below, and there's only some very few references elsewhere. So it kind of helps you to organize your code a little bit better, and you're just not having things that are kind of scattered all throughout your component. So I'm going to talk about this a little bit, and then going to show you, can we do a similar type of thing with what we've already seen before. So Hooks API, there's not too much there, but some of the basic ones is use state, use effect, use context. I'll go in depth with a few of these. So use state, this basically allows you to inject state into functional components. So with this, you end up saying use state, you provide an initial value, then you end up having the current value out of that state, and then a way to update it, so set count. And in this example, we're saying every single time that the set count gets executed, you're re-rendering that function. This entire function gets recalled again. Use effect is, again, another hook, but in this case, it kind of takes over the component did mount or did update or will unmount part of a React class. So in this case, what you do is you say use effect, you pass it a callback function, and you could do even something like a subscription, like what we've seen before. You can say, I want to subscribe to something, and then at the end, I want to unsubscribe from something. In this particular case, if you're familiar with the Hooks API, because I didn't provide another argument at the end of use effect, what this is actually doing is every single time that it renders, it's going to be calling both of these things. So that's not quite what we fully want, but we'll get there. So there's a lot of particular things about hooks. You know, it can't be used in loops. You kind of need to have it at the top of the component. It always gets executed on every render phase, and there's ways to optimize that using some of the other pieces like use memo and whatever else. So there's a lot of things that you're trying to do that kind of works around how it's doing what it's doing. So if we look at what we've done with when added, and we can look at, say, a functional React component, we can kind of see how these kind of interplay. So with when added, whenever we execute that callback function, that's essentially our component did mount, and our return value is essentially component will unmount. The equivalent with React hooks is we say component did mount within this callback function to use effect. And in order to make sure that this gets called once and this gets called once, you know, once at the start and once at the end, you pass it an empty array. Now, yeah, that's a weird particular thing that they've done, but essentially what that means is I can pass different values through that array, and then that allows me to basically say, maybe I only want to execute these things when those different values change. But I'll leave that as an exercise for you guys to dive deeper into if you care to. Now, with we can expand this out a little bit more. And with ArcJS and streams, we can actually say, you know, here's state, and I'm going to have a number of different operators that I want to execute against the state object. And because I can do any number of operators, I can do whatever I want in any sequence that I want to do. So I could end up doing something like before I end up rendering, but if I can go ahead and do something like component will update. So I could just run any other operator and do whatever other function that I want there. It doesn't really matter. Knowing that the next thing that I do on the sequence on line 7 is tap. Tap just means that I'm going to take in the value of state, whatever gets emitted up above, and I'm going to do something. And I'm not going to return any change to the stream downstream. It's basically a way for you to do side effects. So if I don't know what's in a stream, I want to introspect what's in there, you can just pass in console log in here. I could just say console.log, and I could basically get whatever value that comes out of it. So that's pretty cool. Actually, to make this a little bit more accurate, this would be state. So this would be the object that finally gets passed through, that gets emitted. And then after that tap, so after, say, the render function gets called, then you could just do other operators that could basically allow you to do things that happen after the fact that it gets rendered. And if you want to do similar things with hooks, again, you can use useEffect or use layout effect to do those things. And according to whatever your particular case, you can pass it different things into that second array argument. So that kind of shows you a comparison point. So let's write this in a sort of a hooky way. So if we look down below here, we're going to take that previous example, and I just commented it out because, again, I don't want to transpile this, but it's showing you here's what we're trying to achieve, like what the equivalent thing that we're trying to achieve. So if we go up here, we can say when added, when my counter gets added, I want to call this function, I receive that element, and what I'm going to do is I'm going to take that element, I want to get the initial attribute of data count and use that as my starting point. So if I look at the HTML, this is what I'm writing. I'm saying my counter using those tags, I'm passing it some initial configuration. So if I go back here, I can take that initial value, I can pass it in something called uState, and what I'm returning from uState is a stream and a way to update that stream. And everything else looks pretty similar to what we've seen before. We are just taking in that stream, subscribing to it, getting the latest value, rendering to that element, and in this particular case, I'm just putting in new handlers for every single button and doing various updates from there. Now, this useState that I built here is not the same useState as what React Hooks is, but I'm just calling it the same thing and using a very similar API signature just so you can kind of see how that could work together. So in this case, all that I'm doing underneath the hood is I'm using a new behavior subject, and I'm creating an ability to do a .next on that. So that's all that I'm doing there. I can go ahead and go back here and re-execute it. And this is the same example, but done with our technologies that we've been experimenting with. So I can increment, I can decrement, and I can, of course, reset back to 3. So that's really cool. So now I want to go back to one of our other slides, which was this other click one, and we had like multiple subscriptions, different things like that. And I want to do one more cool thing with a sort of a hooky-like thing, and that is how do we group our concerns similar to what Hooks is trying to do. So in this case, we notice that we have one concern, which is I want to unsubscribe from this subscription, and I have another concern, meaning I want to unsubscribe from this subscription. And I'm basically having to pull these things down all the way down at the bottom. So can we use a hooks type of thing to then group our concerns? If I go back here, I am introducing another new custom hook. I'm calling this use callback stack. And just like these other use streams or use hooks, because you're returning an array, you can name these things whatever you want to name them. In this case, I'm calling the first thing when removed and calling the second thing when removed stack. So what I'm saying here is I'm going to go ahead and subscribe to this thing. And then I want to say when removed, I'm going to pass it a function that ends up unsubscribing from that thing right there. So now I've grouped all the logic about the subscription together in one place. I'm going to do the same thing down below here. So when removed, and I pass it a function. And then at the very end, I'm going to be passing that second thing that's up above, which is what I'm calling when removed stack. And what's going to happen is this function, this is a function that will end up calling any number of other functions that get passed in through that first one. So if I scroll down below here, this is using sets, which we've already kind of seen before. I'm creating two different functions, one called add, one called call. And I'm saying if I pass in a function, I want to add it to the stack. And then whenever I call that other one, I want to run through, call them all, and then finally clear the stack, and I'm done. So that's a pretty cool way to kind of group everything together. And of course, if I go back here and just re-execute this, it's the same thing that we've already done, just the code looks a little bit nicer. Any questions about that? I probably have just like 3 more minutes worth of stuff. Maybe. Okay. So the last piece that we just really don't have time to go into, because it's now getting on our hour and a half, is communication. So we've focused a lot on one component at a time, but how do these components start to interface together? So things that you might want to do is, dispatch events or share state. You want to make sure that components can communicate with each other if, they're beneath it, if they're descendants, or if they're ancestors, or maybe if they're in completely other branches altogether. So how do all those things start to communicate? There's another tool that I've built out, and this is something that the teams that I've been working with at Indiana University has been adopting. And so we call this tool Conduit. And this is basically a way to be able to handle all of this communication and organization structure among different reactive components. And so there's a lot of documentation on that site that you can go into and learn more about if you are interested. So here's Conduit. There's some background into how we got to this point. If you're interested, you can go into examples to see things more in use. And these are some of the different patterns that I talk about. And so Conduit is, for one, a series of patterns that helps you to organize these things, but it's also some utilities. So we have Conduit Arcs.js. This is just a few other functions, in this case, just 4 other functions that abstracts out a few other difficulties that you might have when using Arcs.js in this certain way. Again, everything that I have here as examples, you don't have to use it at all. I show you how to use it without it, but it's there as a convenience. And if you want to, we actually use React pretty much everywhere with the applications that we use. And we use this tool, which is basically a quick way of saying, take the output of this stream and use that as props to this React component. So it's just a nice, convenient way of being able to connect those 2 different technologies. So Conduit is, if you're using everything in there, is 1.5 kilobytes. If you're using Conduit, Arcs.js, React, then that makes it another 2 kilobytes. And then kind of in conclusion, if we kind of look at everything, we've put together when elements, we use lighter HTML, we use Arcs.js. Let's just say everything of Arcs.js because we haven't tree shaken it yet. And then for bonus, let's say that you use Conduit. All that together gives us 36 kilobyte, and that's all less than what React and React DOM is out of the box. So anyway, this has been my exploration. It's been really, really fun, and I encourage you guys to play around with what's out there, and maybe there's some cool things that you guys can figure out too.
So maybe 2 questions in front of everybody, and then you're going to hang out afterwards, right? For more. So any questions?
Yep.
What does
this discussion linked any further?
Yes. So all of this, oops, is available on GitHub. So if you go here, the slides are all here with everything that shows you how to run this presentation, as well as all the slides. So, yep.
And I related that, I forgot to mention, but we have been live streaming and recording this, so we'll have a YouTube video theoretically afterwards, so you could rewatch it.
Or share. Yeah. Yeah.
More questions?
Yep.
So with React, like if you use like Redux and Redux
Mhm.
Dunk, how does RxJS play with that, or is it usually recommended to either use RxJS or Redux Dunk?
Yeah. So so if you go to the conduit documentation, a lot of the background that I have there actually talks about Redux a little bit.
Okay.
But I guess a lot of the issues that I have with it is that Redux is synchronous first. If you want to do async, that's middleware. You always have to plug them in, your Thunk, Saga, whatever else. And so I guess the argument with using ArcGIS is that that kind of gives you everything out of the box. You don't need to keep adding more and more tools and plugins and middleware in order to accomplish what you need to do. You can just kind of do it all with one basic tool. But yeah, I haven't used it extensively to really be able to speak to that, but I'm pretty sure that I've seen middleware that allows you to just use observables, or maybe even ArcGIS observables specifically within the context of Redux. So maybe if you're just piecemealing it, I'm sure you can make that work. Yeah.
Thank you.
Mhm.
All right, thanks again, Chris.
Yep.